Welcome to another deep dive. Today, we're going to tackle something pretty popular, Python. But, everyone's talking about it. We're going beyond all those buzzwords to see what really makes it tick, you know what I mean?
hmm
And how does this all relate back to you, the listener? Our guide today is pythontop.pdf. But this isn't just a dry technical rundown.
It's more like we're gonna uncover those like aha moments about how Python went from like zero to hero, right? And how does that interpreter actually like do its thing?
Exactly. We'll even touch on why Python's flexibility can be both awesome and a bit of a headache.
Yeah, it's that double-edged sword sometimes.
So to kick things off, let's step back in time for a quick history lesson. Python, believe it or not, didn't come from some big tech company.
Oh yeah, it was a hobby project actually. This guy Udo van Rossum back in the 80s just kind of started tinkering.
Crazy to think, right? This language that's now powering everything from like websites to AI started as someone's side project.
It really shows how something that's simple and fun can turn into a major force. And that DIY spirit is still at the core of Python, you know?
Yeah, the focus on clear syntax, making it easy to learn, is a huge part of why it's so popular. Even for someone who's never coded before, it's pretty approachable.
Definitely. You can pick it up quickly and start focusing on the big picture without getting lost in the nitty-gritty details.
So Python's backstory and the whole philosophy thing are fascinating, but how does the code actually run? Like, what's the magic behind the scenes?
Okay, so picture this.
Yeah.
You write your Python code. It's in a language that's easy for us humans to understand. Then comes the interpreter. Think of it like a translator. It takes your code and converts it into instructions that the computer can digest. We call those instructions bytecode.
Bytecode. So it's like a middleman between like human language and machine language.
Exactly. And then we have the Python virtual machine, or PVM for short. This is where things get really interesting.
Okay, I'm listening.
The PVM takes that bytecode and manages the whole execution process. Make sure everything runs smoothly. Think of it as the conductor of an orchestra. It brings all the elements together to create, well, a beautiful symphony of execution.
Okay. So the interpreter translates and the PVM orchestrates. I'm starting to see the bigger picture here, but let's talk about Python's strengths. The document we're looking at highlights a bunch of features, but what really makes it stand out?
I'd say from your perspective, as someone who's maybe new to all of this, the biggest wins are its ease of use and the massive support network behind it.
Yeah, it seems like everyone's using Python these days.
Yeah, and that's a good thing because with Python being open source, you've got a global community of developers who are like ready to help you out.
It's almost like having a network of Python mentors at your fingertips. That's pretty invaluable, especially if you're just starting out.
Totally. And because it's a high-level language, you get to focus on solving problems without getting bogged down in how the computer itself works, all those little details.
Yeah, that's a huge relief. I'm more interested in using Python as a tool to achieve my goals, not necessarily becoming like a computer science whiz. But every language has its quirks, right? What are some of Python's limitations?
Right. Every tool has its trade-offs. You know, one thing that people often point out is its execution speed.
Oh, so it's not the fastest gun in the West.
What compared to lower-level languages like C++ plus ER, Python can be a bit slower, especially for tasks that involve a ton of computations.
So there's a trade-off between ease of use and raw speed.
Yeah, you could say that. And then there's the Global Interpreter Lock, or GIL. It's a mechanism that can sometimes be a bottleneck when you're dealing with multiple processor cores.
The GIL, I've heard some stories. How big of a deal is it really?
Honestly, it depends. For applications that rely heavily on parallel processing, the GIL can be a bit of a pain. But for many other tasks like web development, scripting, data analysis, Python's other strengths more than compensate for it.
So it's about choosing the right tool for the right job. Python may not be the best choice for high-performance computing, but it shines in so many other areas. Now let's talk about a topic that often confuses people new to programming, the difference between compilers and interpreters. I always stumble a bit on this. Can you break it down?
Yeah, sure. Imagine you have a recipe, but it's written in a language you don't understand. A compiler is like translating that entire recipe into your native language before you even start cooking.
So you have the whole thing translated up front.
Right, and then you have this complete translated version you can use over and over again. It makes the cooking process much faster, but if there's an error in the original recipe, well, you won't know until you've translated the whole thing.
That makes sense. Compilers are all about efficiency, but debugging might be a bit trickier. What about interpreters? How do they fit into this analogy?
Imagine, instead of translating the whole recipe up front, you have a friend who speaks that foreign language standing next to you, translating each step as you go.
Oh, like a real-time translator.
Exactly. It's slower because you're translating on the fly,
Yeah.
but if there's a mistake in the recipe, your friend can point it out immediately.
So it's a trade-off between speed and being able to catch those errors early on. And Python uses an interpreter, which affects how we write, execute, and debug our code, right?
You got it. That interpreter allows for a much more uh, interactive and dynamic development process.
Okay. Let's shift gears now and talk about something that often trips up beginners. Memory management, specifically stacks and heaps. Can you demystify these concepts?
Sure. Let's start with the stack. Think of it like a neatly organized stack of plates. When you need a plate, you take the top one, and when you're done, you put it back on top. It's a structured last in, first out system.
Okay, so a nice orderly stack of plates. Got it. What about the heap? It sounds a bit more chaotic.
The heap is more like a free-form pile of objects. You can place things anywhere, and
Right.
it's less organized than the stack. When you need an object, you're going to search through the heap to find it.
So the stack is for temporary, neatly managed storage, and the heap is more for like permanent and flexible storage.
That's a great way to put it. And here's the best part. Python handles most of that memory management for you through something called garbage collection.
Garbage collection. Sounds intriguing.
It's like having this invisible cleanup crew that comes in and frees up memory you no longer need.
So I don't have to like manually keep track of every bit of memory I use.
Not at all. Python takes care of that behind the scenes, making your life much easier.
That's great news. Okay. Before we wrap up this first part of our Python deep dive, let's touch on a concept that's all about security. Hashing. What is hashing, and why should we care about it?
Hashing is like creating a unique fingerprint for a piece of data. You take an input, it can be any length, and you transform it into a fixed size output using a special function. And that output, the hash, is virtually impossible to reverse engineer back to the original input.
Okay, so it's like a one-way street. It sounds perfect for securing sensitive information.
Yeah. Like one very common use is for storing passwords. Websites, they don't store your password in plain text. They store the hash of your password.
Oh, so that's how that works.
Exactly. When you log in, the system takes the password you entered, hashes it, and compares it to the stored hash. If they match, boom, you're in.
That makes sense. Even if someone gets access to the database, those hash passwords are pretty much useless without the original input. That's clever.
Right. It's a really important tool for digital security, protecting everything from those passwords to even financial transactions. Welcome back. Last time we dug into those Python foundations. Now let's get into the building blocks of data in Python data types. You can think of them like different containers, each designed to hold a specific type of information.
Okay, containers. What kind of containers are we talking about here?
Well, you've got your strings, which are basically sequences of characters. They're used for storing text,
Yeah.
like sentences, paragraphs, even entire books, you know.
So like the text in a document or the words in a tweet.
Exactly. Then there are lists, which
Mhm.
are ordered collections of items. And the cool thing is, lists can hold a mix of data types. Think of it like a grocery list, you know. It might have items like apples, milk, bread. Each word is a different type of item, but they're all in the same list.
So if I wanted to store a list of, say, my favorite movies, I would use a list in Python.
Exactly. And then there's another container called a tuple. It's similar to a list, but there's one key difference. Tuples are immutable.
Immutable, meaning?
Meaning once you create a tuple, you can't change the items inside it. It's like a locked treasure chest.